Today's episode of the FHIR TL DW video series provides a summary of a FHIR DevDays talk by Google's Will Rosenfeld, using LLMs to process longitudinal records, or more informally, garbage in, good out. The use of LLMs was certainly one of the hot topics during the past FHIR DevDays, and this talk certainly drew in the crowds.
We're going to be focused today on sort of the frontier of what may be possible in the future and what is becoming possible now. So we structured it kind of like an abstract: background, methods, findings, conclusion. We have a new large language model that can ingest massive amounts of data within the context window of the large language model. So first, I just want to say that Google is very invested in FHIR. We believe that deterministic approaches are the right approach for the vast majority of use cases, particularly system-to-system use cases, for exchange of data, etc. But we do see generative approaches as being complementary to deterministic approaches as we move forward. What can you do with it? Well, you can prompt this large language model essentially with an entire multimodal medical record that has full longitudinality, observability, whatever data that you have, and essentially whatever format that you have that data in. And you can pass that in along with your question in natural language. And the infrastructure for this is essentially zero, right? You're just passing it into a large language model, so no pipelines, anything like that. We're going to talk about three general genres of methods. One is deterministic. You all know this pretty well. We kind of color-coded the strengths and weaknesses of this approach. Refined in, reliable out, maybe is one way to think of it. From the generative approach, this is what we're going to focus on. The strengths, instead of being later on, are up front. There's really not much cost to get this up and running. But you do sort of pay a tax later that you didn't pay up front. And that comes in the form of higher latency and cost at time of query, as well as some hallucination risk on the post-process side once you have your result. And then there's also this hybrid approach, sometimes referred to as retrieval augmented generation, but there are also other flavors of it, such as using a large language model to generate a FHIR search or SQL on FHIR logic out of a question that you may pass in, get the data back, and then do some generation on top of it. So this is really sort of a spectrum, more so than just three approaches. And essentially the purpose of this talk is to say, hey, this thing on the right side, this generative-only approach, it's now feasible for asking questions of an entire medical record. In terms of use cases, again, we still believe the deterministic approach is the right approach for the vast majority of use cases. But moving forward, we do think that the hybrid approaches, in particular, we're pretty excited about those, as well as generative-only approaches may play a role moving forward depending on what your use case is. The results are generally pretty good, but there is plenty of hallucination risk. In fact, more hallucination risk than retrieval augmented generation approaches, and of course more hallucination risk than deterministic approaches that are the usual FHIR approaches that you would use, like FHIR search or SQL on FHIR, etc. There is also decent latency and cost per query. So I think these are factors that will come down over time, but the underlying dynamic will probably remain. We created sort of four use cases: search, summarization, synthesize, and we needed an S for the last one, so I called it super helpful multi-turn. But really it's just multi-turn. So search is like essentially a needle or needles in a haystack, right? So anything where you're looking to get those needles back, but you're not really asking necessarily for much more than that. Summarization is, let's say that you want to generate an after-visit summary. So the LLM is going and looking at the record, finding the data related to that visit, and then generating that summary for you. Synthesize is a bit more. Maybe you're asking the model to have some critical thinking in there. In this example, let's say it's for a patient and whether they do or don't meet the prior auth requirements for a GLP-1 like Ozempic, and if so, draft the prior auth form. So again, no pipeline, no anything. We just pass it all in. And then multi-turn, as you can imagine, is chat. So that's actually quite useful for these purposes, because the more that you're able to chat with your data, the more you realize that, or at least for me, that I realize that it's actually what I always wanted to do when I'm talking to a medical record. Just putting something in, getting one response back, that's useful, but having a conversation with your data is really quite powerful. Multi-turn, this example, essentially we pass in the record, and then we say, tell us about the patient related to diabetes. Can you list BMIs? And then, hey, can you evaluate whether this patient meets the criteria for diabetes or pre-diabetes using a standard of care document? So, it isn't as though you just have to pass the data in at the beginning and then you're chatting and you can't add more data. You can add more data along the way whenever it's helpful to you. And then lastly, okay, well, what can you do with this? I think today it's best suited for what we call professional in the loop. We don't just want to say human in the loop, because we don't necessarily think that it should be going straight into the hands of patients, although that's obviously their choice if they want to use the product for that. And it should probably be for proof of concepts today, as opposed to more expansive pilots or going into production. And this approach may have implications for the future of FHIR and when to use FHIR versus when to use FHIR as well as other data. So to come back to that visual that we showed before, let's focus on use cases first. Again, we think that this use case today is currently best suited for versatile proof of concepts that are professional in the loop. I think personally I'm more excited about the lower two of this list of 4 use cases, the synthesize and multi-turn, because there are things that are a little bit harder to do with deterministic systems. It is helpful to have search on multimodal data, but RAG, the hybrid one in the middle, is probably your better bet for that.
Will showed us that the use of LLMs allows us to enhance the use of all sorts of data, including FHIR. FHIR has its role to play in data interchange, but the scope of the data contained within it may well extend beyond the simple interoperability use case. Vivian Neely phrases Google's learnings when it comes to the use of FHIR really well. Let's hear from her.
We need to start thinking about how we can actually gain a lot of insights from data that's coming from multiple different sources and maybe not having to perfectly map all of that. So what I start telling people is, how much can you throw into a binary resource and have some other processing mechanism make sense of it? How much of this data beyond, let's say, US Core or whatever implementation guide is not needed for exchange, but you don't want to lose that information, PDFs, et cetera? Can you, maybe there's just information in raw text that you don't want to parse yet. Throw it in an extension, throw it somewhere. And there's a lot of mechanisms that are coming about that can make this actually so much more meaningful. And we can start finding insights that we haven't been able to from data without making all of the, map everything to the exact specific field that the standard dictates.